Question number 4. This question is about halogens. 4.1. Write the state symbol of chlorine at room temperature. It is an AO1 question, and this question is from group 7 elements, and student must know the properties of group 7 element to answer this question. At room temperature, chlorine is in gaseous form. So the state symbol I'm going to use here, that is G. 4.2. It is an AO1 question. It is from group 7 elements and covalent bonding. Figure number 4 represents one molecule of fluorine. Complete the dot and cross diagram on figure number 4. You should show only the electrons in the outer shells. Here is fluorine electronic structure. Their atomic number is 9 and mass number is 19. Atomic number 9 means 2 electrons in the first shell, 7 in the second shell. Fluorine is non-metal, therefore they make covalent bonding, and the covalent bonding means sharing of electrons. Fluorine belongs to group number 7, so it needs one more electron in its outermost shell to become stable. It can't gain electron or it can't lose electron, therefore it will share electron with other fluorine. If they share one electron with each other, then the outermost shell will have 8 electrons. If this fluorine shares one electron and the other fluorine shares one electron, so they have one shared pair of electrons. Out of 7, 1 electron is used for both fluorine in sharing and making covalent bonding. So number of electrons left behind are 1, 2, 3, 4, 5, 6, and shared ones 7 and 8. Whereas for the other fluorine, we have 1, 2, 3, 4, 5, 6, 7, and 8. Altogether, both the fluorine are satisfied because the number of electrons in the outermost shell, there are 8. Let's count the number of electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Count the number of electrons for the other fluorine. 1, 2, 3, 4, 5, 6, 7, and 8. Four point three is an AO2 question, and this question is from size and mass of atom and group 7 elements. Fluorine is shown here that has atomic number 9 and mass number 19. What is the total number of electrons in fluorine molecule? If you draw fluorine here, that's the 9 and 19. This is another fluorine here, 9 and 19. The total number of electrons present in fluorine are 9 and 9, there are 18. Four point four is an AO2 question, and this question is from group 7 elements, atoms and elements topic. If you read the question, aluminium reacts with bromine to produce aluminium bromide. Complete the balanced chemical equation for this reaction. If you look here in the chemical reaction, we have aluminium, we have bromine molecule and we are making aluminium bromide. There is two more questions. The student must know what is the formula of aluminium bromide. So the formula for aluminium bromide is AlBr3, and student will get 1 mark for writing the formula. If you look here in our chemical reaction, these two belongs to both aluminium and for bromine. There are two aluminium on the right side, but there is one aluminium on the left side. To balance on left and right, we will put 2 here, so we can count 2 aluminium on the left side and 2 aluminium on the right side. We can see the bromine molecule on the left side, it is Br2. Whereas the number of the moles on the bromine on the right side, we can count, that is 2 times 3, it becomes 6. Because this 2 belongs to aluminium and this 2 belongs to bromine also. Whereas on the left side, the bromine is only 2. To make 6, we're going to multiply with 3. Now we count on the both sides, 2 aluminium, 3 to the 6, 6 bromine, 2 times 3, 6 bromine on the right side. 4.5. When chlorine reacts with potassium bromide, chlorine displaces bromine. Cl2 plus 2Kbr. Chlorine reacts with potassium bromide and makes bromine, and potassium chloride 2KCl is formed there. Explain why chlorine is more reactive than bromine. If you look here, chlorine's atom, the size of the chlorine atom is smaller than bromine atom. Because chlorine belongs to period number 3, so it means it has 3 electronic shells, whereas bromine has 4 electronic shells and it belongs to period number 4 of the periodic table. And you can use the periodic table and you can easily see where the bromine and where the chlorine are present. There is strong force of attraction between the nucleus of the outermost shell of chlorine as compared to bromine. Therefore, chlorine will gain electrons more easily as compared to bromine atom. In our model answer, we can see chlorine atom is smaller than the bromine atom because chlorine has 3 shells, 1, 2 and 3. The outermost electron is in the third shell, whereas in case of bromine, it has 4 shells, 1, 2, 3 and 4. The outermost electron is in the fourth shell. Therefore, the outermost shell is closer to the nucleus of chlorine as compared to that of bromine atom. Therefore, there is a strong force of attraction present between the nucleus and outermost shell of chlorine as compared to bromine. So, this distance from the chlorine nucleus is very small as compared to case of bromine there. So, therefore, the force of attraction here in this case is stronger as compared to bromine case. Therefore, chlorine will gain the electron more easily as compared to bromine atom. And some extra information is also given here. The chlorine belongs to period number 3 of the periodic table, so it's a 3 electronic shells. Whereas bromine belongs to period number 4, therefore it has 4 electronic shells.